I'm Nick Federici, and this is Nick is a Better Teacher Than Jake Plaskett. Today, I'll be teaching you Unit 6, which is basically a lot of graphing and solving equations. Let's get started. So first we have 6.1, solving systems by graphing. And basically this means you have to find the intersection, if there is one, to the lines on the graph of two equations. And I'm going to show you what I mean right now. So here's an example. So let's do y equals 1 and y equals x. So first we have to get these, or let's get this one into y equals mx plus b form, which is basically y equals, so x is the same as 1 over 1, x is the same as x, and then plus 0, because that's just implied. And so now we're going to graph these. So here's our graph. So let's do this one first. So the y-intercept is 0, so that's our first point right there. And then we're just going to go up 1 over 1. So up 1 over 1. Okay, so there's our first line. And now for y equals 1, what we're going to do is go, the y-intercept will be 1. So you go up, here's our first point. And since there's no x, it's just a horizontal line across the graph. Just like that. And so to solve these by graphing, you have to find the intersection. And the intersection to these lines is right here. That's the intersection. And that point is 1, 1. So 1, 1. So that's the answer to this problem. Now let's say, let's do another example. You had one that was like y equals 1 over 1 x plus 3, and then y equals 1 over 1 x plus 2. So this would look like, let me do this graph again. Have another graph. So you gotta get, up 2 on the graph. Right here's our first point. And then the second one, so that would be up 1 over 1, so like right here, and then down 1 over 1 should be about right here. So that's our line. The second one, right here, is plus 3, so you go up 3. 1, 2, 3, that's our first point. And since they both have the same slope, but they're different y-intercepts, they're going to have parallel lines that go endlessly on forever. And that would mean that the solution to these equations is none. So the answer would be no solution. And that's our answer. And then also, let's say we have two of the exact same lines. So they're both exactly the same. That would make it infinite solution because they're exact same line. So our answer would be infinite solution if they're both exactly the same equation. And that concludes 6.1, solving systems by graphing. Thank you. Hi, and welcome to another episode of Nick is a Better Teacher Than Jake Plaskett. We're going to be working on Unit 6 again, but this time it's 6.2, solving systems using substitution. So I'm going to show you what that means. Here's our first example. Y equals 2x and 6x minus y equals 8. That looks like a great one. Equals. Okay. So here's what we do. Because the first equation is y equals 2x, to find out what x and y is, we're going to plug this into this, which will look like this. 6x minus y, which y equals 2x, so we can just plug that right in, minus 2x equals 8. See what I did there? Yes, you did. Okay, and then we can just easily subtract these, as you've learned in previous units, I hope. 4x equals 8. And then from here, I'm sure you already know this, divide by 4. What you do to one side, you have to do to the other. Divide by 4. So that would mean x equals 2. And that's 1, but we're not done yet. We have to plug this back into this now. So that would mean, let's go down here, y equals 2, and then we're going to plug in x equals 2, remember? So plug in 2 there, multiply those, so y equals 4. So we have x equals 2 and y equals 4. So our solution to this is 2, 4. That's the answer. Okay, let me give you another example. Okay, so let's say it's y equals 3x plus 1, and then x equals 3y plus 1. So let's start with, we could really work with either, but let's just do y again. So y equals 3x plus 1, right? So we're going to plug that straight into this one. So that would look like x equals 3 times, insert this, 3x plus 1 plus 1. And then we're going to use the distributive property, which I hope you've learned before this, and we're going to distribute that. So that would be x equals 9x plus 3 plus 1. Simplify that a little. X equals 9x plus 4. And then what we're going to do is get all the x's on one side, so subtract 9x, subtract 9x, because what you got, what you do to one side, you have to do the other. So please direct your attention over here, which would give us negative 8x equals 4. Then we gotta get x by itself, so we'll divide by negative 8, divided by negative 8. And that would eventually give us x equals negative 1/2. Okay, so that was a lot, I know, but we're not done yet. Now we have to plug this back into this, which would give us y equals 3, and then x equals negative 1/2 plus 1. So we've got to multiply those together, which is negative 3 over 2 plus 1. Y equals negative 3 over 2 plus 1. And then we add these together, which is the same as negative 3 over 2 plus 2 over 2, which would give us negative 1 over 2. Yes, I know it's a lot of information. Stay with me, folks. And then, so that's our answer. So y equals negative 1/2, which is the same as x. So our answer is negative 1/2, comma, negative 1/2. Sorry, it's very crowded, but right there, that's our answer. Thank you for another episode of, a very long episode. Nick is a better teacher than Jake. I hope to see you next time. Hi, I'm Nick Federici, and welcome to another episode of Nick is a better teacher than Jake Plaskett. We're continuing our lecture on, on Unit 6, and now we're on 6.3, solving systems using elimination. So I'm going to do an example and show you exactly what that means. So let's say we have 3x minus y equals 21, and then 2x plus y equals 4. Okay, so the trick to solving systems using elimination is that you have to have a matching coefficient. And that means you have to have a variable, in this case y, that has the same number attached to it, basically. So, okay, these are both 1y, right? So that would be matching coefficients, or if they were both 6y, or both 8y. But let's say for x, since one's 3x and one's 2x, they're not matching coefficients. But in this case, y is. So what we're going to do, since it's minus y and plus y, we are just going to add this entire thing onto this equation, which will give us 5x, these cancel out because I've added y onto negative y, equals 25. So we're going to divide both sides by 5, and that will give us x equals 5. Yay, that was fast, but we're not done yet. We have to plug this into this now. Or either one, it really doesn't matter actually, but let's just do this one. So 3 and x is 5, so now we can do this. 5 minus y equals 21. Oops. So we multiply these, that's 15 minus y equals 21. So what we do is subtract 15 on both sides. Subtract 15. That will give us negative y equals 6. And because you can't have a negative variable, it has to be a variable by itself. We're just going to switch this around. You could divide it by negative 1 on both sides, or we could just say y equals negative 6. So we have both our answers, so it would be 5 comma negative 6. And that would be our answer. I'm going to do one more example so you get the handle of this one, and then I will be done. Okay. Next one we're going to do is, let's say, 2x minus y equals 6, and negative 3x plus 4y equals 1. So we're going to do the same thing, but look what we have here. None of them are matching coefficients. So here's what we're going to do. We're going to make them matching coefficients. So let's pick y. This one's 4y and this one's just 1y. So what we're going to do is multiply this entire equation by 4, which will put everything into proportion. So 4 times 2x, that would be 8x minus 4y equals 24. And now we keep this one. Now that we have matching coefficients, we can just add them together again. So we're just going to add this to that one. That will give us, let's see, 5x, these cancel out, equals 25. Divide both sides by 5, and that will give us x equals 5. Plug that bad boy back in. Let's do this one. So that's 2, plug in 5, minus y equals 6. So that's 10 minus y equals 6. Subtract 10, yada yada yada, subtract 10. Negative y equals negative 4. And you know we can't have a variable negative, so negative y equals negative 4 is the same as y equals 4. X equals 5, y equals 4. The answer is 5, comma 4. And that is solving systems using elimination. Thank you very much. Have a good day.